Hello everyone, I am Christina Joseph and I am a data science and business analytics intern at the Sparks Foundation. This is my first task, which is prediction using supervised machine learning. Let's see the problem statement first. So in this regression task, we need to predict the percentage score of a student with respect to the number of hours studied. This task consists of two variables, number of hours, which is an independent variable, which help in predicting the dependent variable, that is the percentage score. Well, this is a simple linear regression task as it involves just two variables. Basically, linear model shows that if there is increase or decrease in one variable, it will lead to increase and decrease in other as well. Eventually, it shows linear relationship between independent and dependent variable. Step 1. Importing the dataset. First and foremost, we will import all the necessary libraries which are required to execute code successfully. Panda and NumPy, which are used for data analysis and manipulation, Matplotlib for data visualization, Seaborn for getting more interactive visuals. Here I have read the data from remote link, and as it is printed out, data successfully imported. That means that the file has been read successfully. .head function will use to check if the file is read or not. It gives first few rows of the file, and here we can see in the output that it has given by default first 5 rows of the file. Then to check the dimension of the data frame, we will use .shape function, and as we can see here, it gave output as 25,2, which represents rows and columns respectively. Moving further, .describe is used to view some basic statistical detail like percentage, mean, standard deviation, and so on. So to get more concise summary of the dataset, .info function is used. In the output, it is apparent that the summary includes list of all columns, their data types, that is float and integer, and the number of non-null values in each column. So here we can see there are 25 non-null values, which culminates that there is no null values. That means our data is good to go. Step 2. Visualizing the dataset. So now to visualize the dataset, we have used .plot function where the values of x and y are passed. Along with, I have also set the marker style. One can change it according to their own interest, such as plus, minus, dot, anything. Here I have used asterisk for star, and also I have passed the marker size as 10. So title will be hours versus percentage score. On x axis there will be hours studied, and on y there will be a percentage score. Now we can see that there is a positive linear relationship between these two variables. Next, to quantify the relationship, we will use .core function. Correlation measures strength of linear relationship between two continuous variables along with their direction. So here we can see that there is a positive correlation. The third step is data preparation. We have divided the data into feature and target variable, that is independent and dependent variable respectively. Here we have selected the columns by their position. Next step is splitting the data into train and test set. So from sklearn library, we have imported the train test split. Here I have given the test size 0.2, which means 20% will be used for testing and rest 80% for training the model. And also I have set a random state to 0. Random state basically used to get stable result each time. So one can use any number like 50, 56 and so on. Next, we will implement the linear regression. Here firstly I have imported the required libraries for linear regression, then creating an instance for linear regression as it is a class. So it is a mandatory step to create an instance. Now fitting the model on train set, and we can see the training is complete. As we know, there are two parameters for linear regression. The equation of linear regression line is y is equal to mx plus c, where y determines the slope of the line and c determines the intercept of the line. Then to visualize the model, I have plotted a scatter plot and passed on the attributes and the color. We can see the training score of the model is 95.15. Well, it is a very good score. So without any doubt, we will move further. Step 7 is to make predictions. Now that we have trained our algorithm, we will do some predictions on test data. Here we are predicting the score on test X, and as an output we got an array. Now we will compare the actual data and the predicted data, and we'll see if there is any error by subtracting the two data, that is actual and the predicted values. So we got a data frame showing all the values which we wanted to know. So the test set which we made was to evaluate our predictive modeling. Here I have imported all the libraries for evaluation metrics. We can clearly see the output for each error. Like mean absolute error is 4.18, which is fine. Mean squared error is 21.59 and root mean squared error is 4.64 and R2 square is 0.94. And 0.94 is very good score and the model is performing very well. Now, the main task was to predict the score if the student studies for 9.25 hours per day. We have got the output as 93.69%, which means the predicted score if the student studies for 9.25 hours is 93.69%. Thank you.